In our previous episodes, we often refer to the incredible pace at which renewable energy is being deployed. These are impressive numbers and an impressive speed. However, the transmission and distribution network seem to encounter challenges in keeping up with that pace, which is how they become the bottlenecks of the green energy transition. So, how do we solve this? Hi, and welcome to Energy Explained in Short, where we discuss all things energy and more specifically, renewable energy. In these In Short series, we will tackle a topic and have a discussion, so you get the bigger picture in a small format. Today, we will talk about grid constraints, how it is limiting the green transition and how to tackle this challenge. The shift towards renewable energy sources is reshaping the electricity generation landscape. The push for decarbonization and electrification continues to be strong, and according to a 2024 McKinsey & Company report, renewables are projected to make up to 50% of the global power supply by 2030. Moreover, as economies grow, electricity consumption is set to rise rapidly, and this means that power grids will require expansion to meet the escalating demand. However, the current grid infrastructure is unable to handle this. It's similar to when you move into a new place. You have many things to carry from your old place. If the only person available to carry all those things is you, it will take a long time. That's because you have no power to juggle a sofa, TV, clothes, and kitchen utensils all at once from one place to another. You simply don't have enough hands or the strength that you need. And this means you'll have to ask for help from your friends, family, or support network. Similarly, the current grid cannot handle all the extra energy that will be generated because it lacks the extra network, those extra hands, or the strength to handle and transmit it all. And as a result, if we want to achieve net zero emissions by 2050, which is one of the most known goals of the green energy transition, countries will have to increase their investment in transmission lines and other grid infrastructure greatly, reaching 550 billion euros annually by 2030. That is a lot of money. So, meanwhile, there is a queue. And you may ask yourselves, who handles all of this? How are we approaching these challenges right now? And how do we unlock the queue? Is it just by building new lines? Well, the answer is not that simple. And we will talk about that today in the discussion. This time we have a different discussion partner, but no worries, Christine will be back soon. Today we talked with Joaquin Peirano, US General Manager at Smart Wires. He will help us answer our questions. Hi everyone. Today we are talking about grid constraints, as you all know, and for that we have invited Joaquin Peirano to our Energy Explained podcast. Hi, Joaquin.
Hello, nice to be here.
Yeah, welcome. You are the US General Manager at Smart Wires, which is why we have you today here. Could you tell us a little bit about what you do?
Sure, absolutely. So I lead the commercial team across all of the Americas. So not only US, but from Canada all the way down to South America at Smart Wires. Smart Wires is a technology company that focuses on solving grid constraints. And what we do is we work with utility customers, so the transmission owners of the grid transmission owners, to unlock extra capacity and solve grid issues. And we do it through is more advanced technologies versus what's been out there for many years. We use power electronics, and we have successfully deployed our grid enhancing technology across 4 continents to date. We also provide additional operational flexibility to our customers because what we do essentially it's allowing our customers to manage the grid, manage how electrons flow in the grid.
Cool. So I think it seems like you experience or you work with this in your daily work, obviously. Could we start by maybe pinpointing what the exact challenges are, if you can help us with that?
Yeah, so as everyone knows, the grid is stuck in between generation and load or demand, right? So the big generation plants, whatever it is, and the customer that receives the electricity. The grid is stuck in the middle. We now have a rapidly increasing demand of electricity because we're building data centers, we're electrifying transportation, heat, the industry, and we have economic growth.
Mm.
Electricity consumption is always linked to economic growth, and we're trying to catch up with the grid because the grid is very slow to build. A traditional grid expansion takes about 5 to 10 years and often involves permitting and getting environmental licenses to build a new transmission line. And it also requires massive upfront investment. We're talking about couple to $5 million per mile, or I'll have to translate that into kilometers. Someone do that for me, please. And it's often delayed because it's very challenging when you need to buy the land from each owner that your line is going to cross, and there's multiple negotiations. So in the end, the grid not being able to evolve that quickly for this new energy reality with a lot of renewables and increasing demand, it makes us incur cost in what's called grid congestion.
Mm.
And grid congestion is the cost of not having an ideal grid. Is the cost of having to use different generation sources because you can't use the cheapest one because the
Mm.
route from that cheap generation to the demand is congested, right? To give you an
Yeah.
example, in 2022, in the US alone, we had about $22 billion worth of congestion cost. And the worst part is that when we finally build a new line, we have a physics problems to solve, and I'll touch on that in a second because it's a
Yeah.
very complex issue. So think about when you build a new highway, right? For cars to take that, and you build it from point A to point B. Think about your way to work. Um, Build a new highway with lots of lanes so that many cars can go there. But imagine that people still take the country road that runs in parallel. Well, that's exactly what happens in an electric grid because are the electrons that transfer and conduct the power, they don't use ways. They just take always the shortest path. So if
Mm.
your highway happens to be longer, even if it is faster and more appropriate and you could go faster, the electrons won't take that route a lot. So today we're building the lines that we actually build are not
Mm.
fully utilized because there's a parallel line that was built in 1960 that uses a very old cable that doesn't allow us to transfer more power. So this is at the core of what grid expansion is so complex,
Mm-hmm.
permitting, the topology, the physics of the grid, and why it's so important to find ways to optimize and reinforce the existing grid.
Yeah. What are the agents involved here? Because you're talking a lot of different, or I sense that there are a lot of different people or roles involved in this. So what are the agents?
Yeah, so there's a lot of people involved, and it
Mm.
changes by country depending on how the market is organized.
Mm.
But the main player it's the transmission asset owners, so the company that owns the lines.
Yeah.
And those are the ones trying to build the new lines or whatever it is. It could be transmission, it could be distribution. And they gotta talk with regulators who oversee over their investment, policymakers who are trying to get new generation connected somewhere, or they're trying to build a new factory in this place and need the power to reach there. They
Mm.
need to talk with generation developers who are looking to interconnect into the grid, and it's the transmission owner obligation to provide them access.
Mhm.
They need to talk with us, suppliers of the equipment, whether we can meet the timelines that are required.
Mm.
And yeah, and on the other side, you have the end users, right, of the electricity, every one of us, who will suffer if the a project is not delivered on
Mm.
time.
So it seems like there's different rhythms.
Well, there's a lot of not in my backyard issues, obviously, and
Yeah.
I saw that to your earlier podcast, right? That's something
Mm.
that needs to change. No one wants to see a transmission line going through your property, but there's also difference in how remuneration works for the different parties.
I see. What is your experience, or could you tell us a little bit about what the current progress is in this area, specifically in the US, since that's where you're focused on?
Yeah, well, things have been changing a lot in the U.S. as a result of the prioritization of bringing manufacturing back to the country, nearshoring, uh, investments in data centers, investments in everything pretty much, and
Mm.
electrification, EVs, right? So the federal government has stepped in and is now supporting through, as part of the Inflation Reduction Act. The Department of Energy of the United States is now awarding grants for
Mm.
projects that are fast in delivering benefits, so faster alternative technologies that are not building new lines and are related to just newer technologies that make better use of the grid. So to give you an example, ourselves, we have been beneficiaries of the first set of awards, getting about $56 million to lower the cost of the project, which is typically seen as a barrier for implementing new.
Mm.
And there's also been, just a lot of recognition about these technologies that fit into this group of either alternative transmission technologies or grid enhancing technology gets.
Mm.
Um, we're part of that group. The technology we provide is part of this, and this is reflected in FERC rules. FERC is the Federal Energy Regulation Council. I think that's the acronym. So it's the
Mm.
regulator in the United States. They passed two orders, one in 2023, Order 2023, for interconnection, and Order 1920 for regional transmission planning. Both of these orders are specifically mandating and requiring utilities and system operators to study alternative technologies. And the whole key is they want results fast. They want things that could be done in 6 to 15 months, not 5 years, not 10 years.
What is the struggle when incorporating renewable energy sources to electric grids? Like, is it different from traditional energy sources like coal or gas? And what do they struggle with specifically?
The answer is it depends.
Mm.
Um, the thing with renewables is not necessarily on the intermittency that everyone will tell you about, because that doesn't matter for what when it comes to planning the grid of the future. You always assume the worst case, so you assume that the generation is going to be generating a full load, right? And you
Okay.
need to make the grid available to carry that. The problem is that the best wind the resource and the best solar resource are typically far away from the cities.
Mm.
So you need to be able to transport and evacuate that power to the city. Whereas a coal plant or a nuclear plant are not in the middle of the city, but they can build it, they can be in the suburbs, right? And so you don't require that much network transmission infrastructure to carry the power. And today, every wind developer out there is chasing the same area. They all want to go to this teeny part of the network in Oklahoma or like the wind corridor in the US. And there's no great infrastructure there because we didn't plan for that. We didn't know that this would happen, right? So they run into these bottlenecks. They are told, well, in order for you to connect in this part of the grid, you need to pay and wait for this new line to be built, and it costs 100 million, and it's going to take 5 years. So obviously that kills the project, right? And today we have, I don't remember exactly the number, but there was a Berkeley lab, Lawrence lab report that's called Queued Up, and it talks about how many megawatts of generation are stuck in the queue. Stuck in the queue is precisely that. Is you're waiting for studies or you're waiting for something to be built so that you can actually go and connect into the grid and start generating. So we have almost as much generation waiting to connect it than the one that we have generating. And that's a worldwide problem, by the way.
Yeah. So how do we unstuck it, those bottlenecks?
How do we unlock the queue? Unlock the queue. And I use that term because there are also some reports out there, one by the Brattle Group, that talks about unlocking the queue. So you might want to check it out for everyone who listens to this. So there are obvious ways to unlock the queue. You're going to have to build new lines. But that's going to take long. So there's things that we can do in the interim. And that's where we have this advanced grid technologies that come in. They're ready. They've been proven over many years, but they need more adoption. This new technologies will ultimately remove the bottlenecks, and it will solve the country road that we just talked about, right? So that the electrons can flow through the highway that we just built, right? So we need to optimize, and we need to change how the grid operates, how we need to be able to control where the electron goes, which unbelievably we don't. Today, physics does that for us.
Once new lines are constructed, what happens with the old ones? What happens with the old infrastructure?
It's a really good question. So depending on the type of technology or conductor you use, a transmission line can have about 40 to 60 years worth of asset life, and it's already being paid for. So you don't want to throw it away. What you want is make sure that it's not acting as a bottleneck. Now there is also some other technologies that we have today. We have better cables than what we used to have in the 60s. We have cables that are lighter and are capable of carrying more power. So the older lines, if they're already at their end of life, you should change the conductor. Now that sometimes means that you need to change the structures too, and it's not an easy project to do because you need to do it with the grid while the grid is on, right? So it's because we can't afford to stop the grid to do maintenance, right? So that's the tricky part, but it is possible. It's been done, and there's no single or silver bullet here. All technologies will have their place. If you have a very old line, go replace that because it's already near the asset life. It's not so old. It's in the 20-year, and don't throw it away. Just reroute the electrons, right? That's I think is the key.
Okay. That was very interesting to learn about. So thank you very much, Joaquin, once again for your participation.
Absolutely.
And thank you also to our listeners for tuning in once again. We hope you enjoyed this episode.
Thank you.
Thanks for listening to the Energy Explained in Short series. If you found it interesting, follow us and stay tuned for more episodes to come in the future.